You know that feeling, right? You get a brand new computer, it's blazing fast. And then, a few months later, it starts to feel just a little bit sluggish. Well, the answer to why that happens might not be what you think. Today, we're going to pull back the curtain on the hidden world of primary memory, the real unsung hero behind your computer's speed and performance.
Think of it like this. Your computer's memory is your desk. When it's nice and clean, you can find anything you need in a snap. But what happens when you start pulling out more stuff? You open a dozen browser tabs, a couple of documents, maybe a music app. Suddenly that desk is a total mess. You're spending more time just looking for things than actually working. Well, that's exactly what's happening inside your computer when it slows to a crawl. It's just struggling to keep track of everything at once.
And that desk, that cluttered workspace we were just talking about, in the world of computers, that's what we call primary memory. This is where all the action happens. It's the high-speed command center, the direct line between the computer's brain, the CPU, and every single task you throw at it. This isn't some dusty library for long-term storage. This is the nerve center for everything you're doing right here, right now. Okay, so when we dive into primary memory, we're really talking about two main players, RAM and ROM. Now, you've probably heard these terms before, but they have very different, very specific jobs. You can think of one as a temporary notepad, constantly being written on and erased, while the other is more like a permanent, unchangeable instruction manual that the computer can't live without.
First up, let's talk about RAM. This is your computer's short-term memory. It's workbench. It's where your machine keeps all the stuff you're actively working on. Your web browser, your music player, that video you're editing. But here's the crucial thing about RAM. As soon as you cut the power, poof, everything in it just vanishes.
So yeah, RAM is all about speed. It's lightning fast, but it has a terrible memory span. That's what volatile really means. It completely forgets everything the second the power goes out. But you know what? That's actually a feature, not a bug. It means your computer gets a totally clean slate, a fresh start, every single time you turn it on, ready for a new session. And on the complete opposite end of the spectrum, we have ROM, the wise old sage of your computer. It holds all the basic, fundamental knowledge your system needs to function, and it's always there, even when the power is off. It's literally the very first thing your computer talks to when you hit that power button, holding the essential instructions that get the whole show up and running.
So let's just put it all in a nutshell. RAM is the fast-paced, ever-changing workspace for all your active apps, and ROM is the steady, unchanging foundation that your computer is built on. They're two sides of the same coin, and you absolutely need both for your computer to work at all.
But hang on a second, there's a problem here, a big one. Your CPU, the brain of the whole operation, is like a cheetah. It's built for these incredible bursts of speed. Your RAM, while pretty quick, it's more like a turtle. So how in the world can the turtle possibly keep up with the cheetah? And the short answer is, it can't, not by itself. And that's exactly why we need a whole other level of memory, something even faster than RAM. We need a memory that can actually keep up with that cheetah. So let's meet the special forces, cache and registers. Cache is pretty much your computer's secret weapon. It's this tiny but incredibly fast chunk of memory that sits right next to the CPU. Think of it like a personal assistant for your computer's brain. Its whole job is to anticipate what the CPU will need next and have that information ready to go, bridging that massive speed gap we talked about. Okay, let's unpack this a bit, because it's pretty cool. Cache is kind of like a set of those Russian nesting dolls. The smallest, tiniest doll, L1, is built right onto the CPU itself. It's the absolute fastest, but it can't hold much. Then you've got the next doll, L2, which is a bit bigger and a little slower. And finally, the largest doll, L3, which is the slowest of the three, but holds the most. Your CPU always checks that tiny L1 doll first, hoping to find what it needs for maximum speed. And just when you thought cache was fast, we go one level deeper. We're talking about registers. These are the brain of the brain. They aren't just near the CPU, they are literally part of the CPU. These are like the individual neurons, firing off calculations at the speed of light. They hold the exact piece of data the CPU is working on in this very nanosecond. This is what makes your computer think. So it's really important to get this. These different memory types aren't competing with each other. They're collaborating. It's a team effort. So let's put all these puzzle pieces together and see how they work in perfect harmony to create this symphony of speed. This right here is the pecking order of your computer's memory. The CPU is incredibly demanding. It always looks for what it needs in the fastest place possible first, the registers. If it's not there,
It checks the cache. Still no luck? Then it has to go all the way out to the bigger, slower RAM. It's a simple system, but it's incredibly effective at making sure that Cheetah, the CPU, is almost never left waiting. And really, the performance of this whole system just boils down to two things: a cache hit or a cache miss. A cache hit is awesome. It's like going to the library and finding the exact book you need on the very first shelf you check. It's pure efficiency. A cache miss? Well, that's a bummer. That's like having to search the entire library, aisle by aisle. That tiny delay is the difference between a snappy computer and a slow one.
Let's make this super clear with a gaming example. The moment you power on your console, that's ROM saying, "Hello world," and checking that all the hardware is good to go. When you load a new level, that's RAM pulling in all those beautiful graphics, textures, and sounds. While you're running around, cache is busy keeping things you use all the time, like your character model, ready for instant action. And that perfect headshot you just made? Yep, that was the registers, calculating the bullet's trajectory in a flash.
So there you have it, the whole family of primary memory, all laid out. You've got the lightning-fast registers, the speedy cache, the reliable workhorse RAM, and the wise old ROM. Each one has its own special job, and they all work together in this beautiful high-speed dance to make your computer the amazing machine that it is. So what's next? As our technology gets more and more complex, from mind-bending AI to photorealistic gaming, our need for speed is only going to grow. I mean, will we one day see RAM that's as fast as today's registers? Or are we going to invent a whole new kind of memory that we can't even imagine yet? The future is unwritten, but I can guarantee you one thing for sure. It's going to be incredibly fast.